All right, problem number 4. We're at Monty's Diner, and the lunch special is 5 items for $5.99. And the items you have to choose from are Spam, bacon, sausage, eggs, and baked beans. Okay? But there's some rules here. You can't just choose any combination that you want to. At least one of the items has to be Spam, and you can have as many servings of spam as you want, up to 5 servings, but you can have no more than 1 serving of each of the other 4 items. Okay? And the total number of items has to be exactly 5. So, one other thing is that the order of the items doesn't matter. So, spam, spam, sausage, baked beans, and spam is the same as spam, 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 baked beans, and sausage. Alright? Which makes sense. I mean, if they're all on your plate, it doesn't really matter what order you put them on the plate. So, the question asks, how many different variations of the lunch special can be created? Alright, well, first of all, I'm going to scroll down a little bit here and give us some more room to work, because this problem statement takes up a lot of real estate. And I'm going to actually show you 3 different ways to approach this problem. The first way is probably the most common way to start this problem anyway. You may not finish the problem this way, but you might start the problem this way. You might think to yourself, well, let's see. I've got to have at least 1 spam. Okay, so we'll put down spam. So I could have 1 spam, I could have 2 spams, 3 spams, 4 spams, 5 spams. 5 is the maximum. So what if I do case 1, where I say, okay, well, let's just say we have 1 spam, and then I want to fill in the other 4 items. So we have 4 remaining items, and we want to fill them in with these 1, 2, 3, 4 options, right? And we can only have 1 serving of each, okay? So we can have 1 or we can have none, but we've got 4. If we say case 1, case 1 is just 1 spam, and we've got 4 items, and we got to fill 4 slots, and we can't repeat any of these items, so we can't have 2 servings of bacon. Then that means we just have 1 choice, right? This would have to be bacon, sausage, eggs, and beans. Alright, so that's case 1. We get to go on and do case 2. Okay, let's say we have 2 spams. And we have spam. Okay, and then we have 3 slots to fill. Okay, so now we have 4 items and three spaces to fill. So we're trying to choose 3 of these 4 in any combination. So you could list them out. You could say, okay, we got bacon, sausage, eggs, bacon, sausage, beans. But you kind of get the idea, right? Case 1 is 1 spam, case 2 is 2 spams, case 3 is 3 spams, case 4 would be 4 spams, case 5 would be 5 spams, right? And you'd come up with all of the different variations of those cases, and you can add them up. And you probably don't want to sit here and watch me list out all those possibilities, so I'm hoping this will work. I've done this offline. Whoops, I don't want to paste it there. Paste. Oh, okay, it's kind of big, but I'll make it smaller. Let's see, let me move it over and make it a bit smaller so that we can see what we're doing here. Okay, so all I did was I listed out everything systematically. Okay, so you can see case 1, we have spam, bacon, sausage, eggs, and baked beans. For case 2, we have 2 spams, And then we have bacon, sausage, eggs, bacon, sausage, baked beans, bacon, eggs, baked beans, oh, sorry, no more bacon, sausage, eggs, and baked beans, okay? And then we have 3 spams and 4 spams and 5 spams. So that's just a way of systematically listing um, all the possibilities out, and then we would count them, and we would get 16. I could number them for you, but if you count all these, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 different ways. Okay? Now, that is probably the difficult way to do it, and it's also really easy to miss one of the possibilities. So I want to show you a couple other ways to do it. And here's what I want to do. I'm actually going to use this case idea, but instead of listing all the possibilities, I want to use combinations. Okay, so let's see. I guess case 1 doesn't change, right? There's only one. Oops, I lost my P. Spam. There's only one way to choose 5 items with only 1 spam. Okay. In case 2, we'd have 2 spams. Okay. And then we'd have 3 items remaining to choose, and we can write that as 4 choose 3. Okay, so we want to choose 3 items of the 4 that that we have to choose from, right? So here's what we do. We say, okay, we have four choices for the first item. We have 3 choices for the second, and we have 2 choices for the third. Okay, but in a combination, order doesn't matter. So we have to actually divide that by the number of ways that we can arrange the 3 items that we've chosen. Okay, so we divide that by, okay, so after we've chosen 3 items, how many ways can we arrange it? Well, we can have 3 items for the first position, for the first position in an arrangement, and 2 choices for the second position, and then one choice for the third. Okay, and so the top, the numerator here, is a permutation of all of the of 3 items taken from 4. And in a permutation, order matters. Okay, so bacon, sausage, eggs would be different from eggs, bacon, sausage. Okay, but we want to get rid of those duplicates, so we have to divide it by the number of ways that we can arrange the 3 items once we have them chosen. Okay, so that's how we get a combination. Okay, and you can see we can cancel the 3 and cancel the 2, so we just get 4 different ways that we can choose 3 items from 4 to fill out our. So we have 2 spams, and then we have 3 more positions to fill, right? 3 more items to fill out our 5 that was required. Okay, so so we're choosing from bacon, sausage, eggs, and beans, and we want to choose 3 out of the 4. So there are 4 ways to choose that. So for case 2, where we have 2 spams, we have 4, and that agrees with what we have over here. Okay, so that's good. And up here, I could have written this as we have 4 items, and we want to choose 4 of them, and that obviously is 1, right? Because there's only one way, if order doesn't matter, to choose 4 items from 4, right? So 4 choose 4 is 1, and so that's one case, and that that corresponds to this, and case 2 corresponds to this. All right. So we can go through that and just do case by case. So let's do case 3, where we have 3 spams. Alright, so we'll have, we'll have spam, 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 and then we'll have 2 slots to fill. Okay, so we want to choose 2 items from 4. So we can write that as 4, choose 2, and that's equal to 4 times 3 over 2 times 1. Okay, we've got 4 choices for the first item, 3 choices for the second, but order doesn't matter, so once we have 2 items chosen, there are 2 choices for the first one in the order and 1 for the second, so we just have 2 ways that we can arrange those 2 items. So we had to divide it divided by 2. So you get 12 divided by 2, which is 6. Okay, and you can see that here we have 6 items. Oops, not a very good curly bracket, but so that corresponds there. All right, and let's keep going. Case 4. Okay, now we can have 4 spams, right? We have 4 spams. Oops, that's not very good. 4 spams. Alright, and so we'll have, I'm not even filling it in, we have spam, 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 and the 5th item, right? And then we've got 4 items to choose from to fill that 5th slot. So I don't even really have to write it. I mean, I could write it out as 4, choose 1, but you can figure out that that's 4, right? Because we have 4 items to choose from, and we want to choose one of them, and we have 4 ways to choose it. And then finally, case 5 is 5 spams. Alright, so we have spam, 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 spam. And if we have all 5 slots filled with spam, then we can't choose any of the bacon or eggs or sausage or beans. Okay, so there's only one. So basically this is 4 choose 0, right? We can't choose any of the other options because we filled them all with, we filled all the all of our servings with spam. So there's only one way, okay, and that's down here, okay? And you can see here, oops, this corresponds to this, and this corresponds to this, okay? So now we can just add those all up. We have 1 plus 4 plus 6 plus 4 plus 1, and thank goodness we get 16. So, so the total is 16. All right, cool. I want to show you one more way, an even easier way to do this problem, okay? So imagine you're standing there at the menu board and you're trying to decide what to have. Well, you know the first item has to be spam. There's no choice, you know, because one of them has to be spam. So that's a given. We're going to have one spam. And then you have a choice of, the choices are off the screen here, but they were, what were they? Bacon, sausage, eggs, and beans, right? And you're looking at the menu. I can only have one serving of each one of these. So I'm going to say, well, do I want bacon or do I not? Do I want sausage or do I not? Do I want eggs or do I not? Do I want beans or do I not? Okay, so there's really 2 choices for each of these different items, right? It can either be on your plate or not on your plate, okay? So you have 2 choices for whether you want bacon or not, 2 choices if you want sausage or not, 2 choices if you want eggs or not, and finally 2 choices if you want beans or not. And then once you've decided, do I want bacon or not, sausage or not, eggs or not, beans or not, then you know, whatever, you know, the other